let's take a look at the exercise set in 1.5. All right, now here we go. So 1.5, now question number 1. This is a fairly straightforward, right? You only needed to see whether or not it converges or diverges, depends on R. So if the absolute value of R is smaller than 1, it converges, but if its absolute value is larger than 1, then it's diverge, right? Okay, now for example, this one is equals to 1, so it's not smaller than 1, so absolutely this is diverge. Now this one says find the sum if it exists, infinite. All right, if it exists. So now, first of all, we have to see whether or not the common ratio, the absolute value is smaller than 1. Now, for example, this one, sure, 1 over 2 divided by 1 is negative 1 over 2, so that's smaller. 1 divided by 3, yes, 1 over 3 is smaller. And this one, sure, this is a smaller number divided by a larger number. Of course, you know, it is smaller than 1. Now this one, 3 over 2 divided by 1, then that is larger than 1. So this one does not exist, right? So very quickly, then you can also discover, so whenever there's a root, it might just be a little bit mind-boggling, but not necessarily. So for example, this would be a2 divided by a1. So what I'm trying to get at is to calculate the common ratio. So then that is negative 2 divided by root over 2. Now we talked about a number 2 and the root over 2. Of course, 2 is larger than root over 2. Now therefore, the absolute value is not smaller than 1. So then this one is no. Now this one is interesting, is this all negative exponents. That should be it should be not a issue. However, let's rewrite it. So that means this one divided by this one, the a2 divided by the a1. So what's happening here is 1.05 to the power of negative 2 divided by 1.05 to the power of negative 1. So here, use the power law, or the exponential law, exponent's law. This will be 1.05 to the negative 2 subtract negative 1. So that means plus 1 and negative 2 plus 1, that equals to 1.05 to the power of negative 1. So 1.0, then that means 1 over 1.05. So then this one definitely is smaller than 1. So then we can calculate this one. Okay, well, this is just basically plug the number in and you will be able to calculate it. This question is interesting again because now it's written in the summation notation, or the called the oh my gosh, my mind just went blind. So it's what is the not asthma? I'm thinking of the asthma because I've been coughing or sneezing. So for this notation here, I just happened to do this question. Okay. So this question now is because this is 4 over 3, 1 subtract k. Well, k started from 3. So therefore, my first term will be 4 over 3. Yeah, that's called a sigma notation. I'm so sorry. My mind just like sometimes either going too fast or going too slow. So 1 subtract 3. So that becomes 4 over 3 to the power of negative 2. So in this case, if you're very fluent with negative power, that means you just flip the fraction inside and it becomes a positive power. So that becomes 3 over 4 to the power of 2. So that's your A1. Now your A2, you already should know the A2, because the A2 will just be the 4 over 3. So that will be 1 minus 4. So then in this case, that will be 4 over 3 to the power of negative 3. And again, flip 3 over 4 to the power of positive 3. Now divide A1, divide A2 over A1, then you got ratio is 3 over 4. So in this case, okay, well then in that case, that means from infinity, then my A1 is 3 over 4. So I sometimes I don't like to write this sigma notation. So I just use this s to the infinity. And that equals to my first term value, which is that divided by 1 subtract 3 over 4. So then that is 1 over 4. So then that means 3 over 4 to the power of 2 divided by 1 over 4. So that means, this just means 3 over 4 to the power, I'm just going to rewrite that. The reason why is because I want to cancel. So that means that multiply by 4, right? Another thing is that I've taught different students to say this, you know, this one divided by 1 over 4, the 4 flips to the top. Okay, so this 4 is the bottom of the fraction of the bottom of this another fraction. The bottom of the bottom flips to the top. Okay. When I have time, I probably can talk about these funny things with you, but this year we just don't have time. However, now there's a 4, and then 4 to the power 2 cancels. So then you got top is 9, bottom is 4, and then that is our sum. Okay. The next question, this one, to rewrite into the repeating decimal, I would suggest you don't really bother with this because it's I don't find it's too meaningful. I rather even just use the way that I demonstrated in the lesson to figure out how to change a repeating decimal into a rational number. What does that mean? It means change into a fraction. So I think this is not too important. Okay, now this question I find is very interesting because I'll solve for x. All right. Now, so what's going on here? Now, first of all, your x. So the a1 just equals to x, right? A1 equals to x. Now your a2 equals to x to the power of 2. So therefore our r equals to x, right? And then this one, if the sum becomes that, so then what is using the sum, the formula for the sum? That means the top, so a1 over 1 minus r, then that is becomes a1 is x, so it is x, 1 minus x, all right? And now we're being told this sum to the infinity is 2 over 5. So that means x over 1 minus x equals to 2 over 5. Okay, now cross multiply, that means 5x equals to 2 multiply by that. Open it up, equals to 2 minus 2x. Left hand side, 5x. Okay, now I'm going to move this to the other side, so that becomes 7x equals to 2. X equals to 2 over 7. Done. Okay. Now let's take a look at the question B. Question B is very interesting. Now from B, then you can try question D if you're interested or have any time to have fun with. I know how busy all of you are. Now let's take a look at this one. Now this one means your term, your A1, I probably should just use a different color so we don't mix the two questions. So I'm going to erase this guy. Okay. And then I'm going to use the green color. So for this question B here, so my A1 now equals to 1, right? Because when I equals to 1, that is 0, so my A1 is 1. Now what is my A2? My A2 now is 2x, right? Because 2 minus 1 is 1, so my A2 is that. Then therefore my R equals to 2x. All right, my R equals to 2x. So then I'm going to multiply it, same strategy as this one here, using the sum to infinity. That means my A1 is 1, and then this A2 is, not A2, my 1 minus R is 1 minus 2x. Okay, now this one equals to 2 over 5. Okay, now similarly do the cross multiply, and then that equals 5 equals to 2 subtract 4x. All right, so then I'm going to move the 4x over that way, so that equals 4x equals to 2 subtract 5. So x equals to negative 3 over 4, right? So then that is negative 3 over 4. So in this case, negative 3 over 4, that means my A2, so my A2 equals to 2 multiplied by negative 3 over 4, and then cancel this one. So my A2 now equals to negative 3 over 2. Then take a look at my A1 is that one. Then my R now becomes, or by the way, you can just bring this one here in here. So bring this one in here. That means your R equals to 2 multiplied by negative 3 over 4, right? So that means that is your R. That is negative 3 over 2. Now again, this is this absolute value is larger than 1. Therefore, your sum does not exist. There's no such a sum. All right. So similarly, try question D if you're interested. Otherwise, I will be just making this. I did this question. I find it's very interesting, but it will be making the video too long. Now, again and again, I want to demonstrate question number 19 because, as I said, it's so classic, and this is already the third time I mentioned about this exact type of question. Okay, so now all the time when you make sure these kind of ball, it definitely draw a diagram. It is much easier for us to understand. So the ball is down here, being dropped down, bounce back, drop, bounce back, and then down, 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 down. So in the very end, it will be with 0. Infinitely, if it bounces infinitely, in the very end, it will be 0. It will not be bouncing infinitely, but that means it's 0. So then we talk about, now we consider every single bounce, it is just a term, right? But then this term is reduced by 3 over 4. Okay, so now this is a 10, all right? So that means the total distance, the S infinity, when it's becoming finally stops, that is, my first one is 20 because it's dropped from 10 meters down. So that first one is 20. And then the common ratio is 3 over 4. So that means that subtract 3 over 4, then that equals to 20 divided by 1 over 4. So this one flip to the top. So 20 multiplied by 4 equals to 80. Now, as I explained before, from this 80, we have to subtract the first 10 because the first 10 does not exist. It dropped from the top here to come down. So the total distance is 80 subtract 10 equals to 70 meters. All right, okay. Now here it's basically exactly the same thing. So then this one is not infinite, but this one has 10 bounces. So okay, so now 10 bounces means S to the 10, that equals to, again, my first one. Well, then this time I cannot use the infinite geometric series formula. Then I have to use the other guy. The other guy is finite because this is 10 bounces is finite. So then that means 20, my first one, 1 subtract 3 over 4 to the power of 10. This is just a tedious calculation, but you got a calculator. And over, same thing, 1 subtract 3 over 4, that means that's 1 over 4. So then immediately this 4 goes to here to make 80. So as a matter of fact, it's 80 multiplied by this 1 subtract this 3 over 4 to the power of 10. This is just use the calculator to calculate it. Then that is 75.4949. So 4949 to 495 meters. Now again, this 75, again this number needs to be subtract by 10, and then you got 65. So then that is 65.495 meters. The last one is what is the total distance traveled after the 10th bounce? Then of course your total, if you're infinity, go down to the infinity, is 70 here, and the first 10 bounces will travel for this. Then you use 70, subtract this. Then that is your answer. I didn't even calculate this. All right. Yeah, I didn't even calculate this number. So whatever this number is, you just use your calculator to calculate, and this many meters. All right.